Well, good evening, everyone, and welcome to another edition of the Memphis Astrophoto Group Zoom meeting. Uh, we're on our fourth or fifth month now here of getting together once a month on the Saturday night near the full moon to talk about astrophotography and um, the everything involved with that from telescope control to camera setups to different telescope arrangements. And then on cloudy nights, what to do with all that data you go out and collect and that image processing. And we've kind of uh, dove in head first into image processing. We've done a little bit of looking at what you can do with Photoshop and some other shareware pieces of software out there. And then, since several of us have got the program that's called PixInsight, we kind of dove in headfirst into uh, trying to expand our skill sets. And in that area, we have someone who's got a lot of experience with our group in PixInsight, and he's being a mentor to the rest of us and extremely helpful. And we're kind of going to ride on that theme for a little while and uh, go during these meetings, have something of a workshop or tutorial sessions around PixInsight and working with several data sets that we've purchased for the group to work with and experiment with. There is a free, I think you get a 30-day trial with PixInsight. So when you think you're ready to start playing with it, you might want to download the 30-day free trial and start playing with it. We have a shared drive in the cloud where I keep all these files that we're working with. I can, if you, well, that's what I wanted to bring up here. So we have a Slack group that we use in general to communicate with each other. If you want to be a part of this group, you need to send me an email, Rick, RIC, at memphisastro.org, and I will get you set up in our Slack group. We also have a cloud drive that I can give you access to and set up a directory there for your own workspace. We got 4 terabytes of drive space, so we're not going to run out anytime soon. And and then of course we have the Memphis Astrophotography. Well, we have the Memphis Astronomical Society Facebook page where many of us enjoy posting the results of our uh, work and experimentation in astrophotography. And you certainly don't need to be an expert in this arena, and we have people in all levels of skill and interest in astrophotography, sharing what they're doing in the Memphis Astronomical Society Facebook page. So uh, feel free to do so. No advertising. If you're interested in this as commercial, go someplace else. We're all amateurs. We're not about doing any of this for money. So uh, that's my disclaimer for that. Um, I think that's about got the preliminaries. And do we have anything we want to discuss before we dive into tonight's PixInsight tutorial or workshop?
Well,
Anybody got any particular subject they want to bring up before we do that?
how about introductions? I mean,
That'd be great.
we got introduced to Ryan, and I know Ann, but I don't know. Let's see, who just got off here. I lost somebody.
So we've got some people that aren't sharing video, which is fine. And but if you'd like to introduce yourself, Cameron, I don't know that you've been with us before.
Hey, Rick, I invited Cameron to be on this call tonight. He's actually posted several images to our Facebook group, and he's doing kind of right in line with what we've been doing, purchasing data sets and doing some image processing. So that's kind of the reason I invited him to be on tonight. And he's got a great name for an astronomer, right? Caldwell, Cameron
Yeah,
Caldwell, Caldwell
right.
Optic.
He
Other
should
than
create a
Messier, I
catalog.
can't think of a better name.
Yeah,
So
create a catalog.
I want to officially welcome Cameron to the group. And Ryan, I don't think I've met you yet. Welcome. And a few other people that looks like we got some new faces. So hope you guys get some value out of tonight. You're spending your Saturday night with us. So
Yes, sir. Nice to meet you all.
Ryan is a soon-to-be student at Rhodes and working with Ann, and and I'm jealous that he's going to have access to that telescope on top of the science building over there. It's almost enough to go back to school over. All right.
You know, the other one I don't know is, I think you said Richard. Is that right? Richard Kimball. Is
Yeah.
Yeah.
Richard, you want to?
Yes, Richard Kimball. I'm here in Memphis, in Midtown, and I started with my first scope probably about a year ago, and just got lucky with some things, and just recently been working hard to get some other things. So I'm total novice at editing all this. So I'm very interested to be part of the Facebook group and to see what skills I can learn, because again, I need to understand how to photo process better and things like that too. So this is right up and needed it right at the right time too. So
Cool.
but nice to meet everybody.
I'm always amazed when that might sound kind of arrogant, when I figure out that I don't know something. You know, it's learning what you don't know is always the trick. Always welcome. All right. Anyone else care to introduce themselves? That's all right if you don't. You're welcome to listen and participate when and if you want to.
I guess with me posting a few images on the page, might as well introduce myself. I'm from Memphis, Tennessee as well, and I have lived there 24 years. But I just started doing astrophotography about a year ago. I originally started out with very basic equipment, a Canon XSI and a static tripod, nothing fancy. It was only able to pick up a couple stars in the sky at max. And I had some budget issues. I'll be honest, everyone has budget issues at some point or another.
Sure.
I ended up finding out a website, telescope.live, and they have a few different plans available depending on what you decide to subscribe to. So most of the images that y'all see on the page from me are data sets that I get back from that subscription. It's still pretty neat to be able to get fresh data from several different scopes and cameras from different observatories from all around the world. It's not the same as being hands-on with it, though. I will be honest with that. I definitely would prefer to be hands-on with it again at some point, but it's still fun, and it gives you the chance to practice your processing skills. And that is why I feel like I've come pretty far within the 1 year that I've been doing this. The more and more data you get just really gives you that ability to keep testing and testing and testing until you get it right where you want it. And it's about what makes you happy. That's why I like doing this.
Yep.
You've had some very nice results too that you posted on our Facebook page. So
I appreciate it, man. It's a lot of work, but I've kind of noticed that when you enjoy something, it's not much work as it is just fun.
Yeah.
It still takes some time and some trial and error, but most of the time it ends up paying off.
Well, welcome to the group.
I appreciate it. And I just wanted to let you all know, I'm not sure if this is an issue or not, but I actually just moved out of Tennessee yesterday.
It's not an issue at all.
I'm in North Carolina now, but I'm about to start saving up to get my own equipment because I'd like to be able to eventually kind of lean off of that, data sets a little bit, do some fresh stuff.
Understood. No, it's no issue at all. In fact, welcome. We actually have a regular member from Texas who I guess he's going to be with us tonight.
I did get a hold of Alan. He's going to be joining us here momentarily.
Hello.
He's on
There he is. I need him for part of the presentation.
Yes, great.
He didn't know that, but he.
Well,
How are y'all?
I think I've covered what I wanted to. Jeremy, you got anything else?
Nope, not a whole lot more to add, just to say welcome everyone. I think what's interesting, this is an interesting sequence as far as learning the skill set. Instead of spending time, with polar alignment and plate solving and gathering the data, let's actually start with a purchase data set, go through the image processing aspect of it first, get that down, and then you can go back over here, because not all of us has a sky shed in our backyard. So, being able to break this up into modular chunks, I think is going to be very valuable. And we've discussed this before, but Ann can really help out with this effort long-term as far as our overall, say, big picture vision of this, which is to have a sequential, maybe almost like course outline of different modules that can help aid somebody in learning this. So this is very much raw right now. We're developing this as we go. You're getting an insight into kind of how the sausage is made. But when you get some of the best and brightest minds together, it can be kind of fun to see how this comes together. So my role in all of this is essentially a fly on the wall and just kind of observing what's happening here. And it's going to be fun to see how this comes together.
All right.
Cameron, you're going to see some of the data of the Tarantula Nebula that we have purchased. I heard Rick talk about it. It's on the cloud drive. There's 4 really outstanding data sets there.
Oh yeah, I'm be very glad to see that. Just curious, do you know what the exposure time was?
Oh, 25 to 30 hours.
Oh wow, that's amazing. I think the one that I did a few weeks back was maybe somewhere between an hour and a half or 2-ish hours. Not a lot. So it's really hard to pull out as much detail as I got in it, but I'm looking forward to seeing that. That's a lot of data.
Well, moreover, it's a CDK 20, I think, telescope and
plane wave.
Yeah.
Really, really great. They have such crisp, great details all the way through.
And he's down in Australia. That's even make in the backcountry. So,
Perfect weather.
Perfect.
All right. So you want to get started, Merrell?
Yeah, you gotta let me, I guess, share my screen, I suppose. And I'm going to count on Alan and on the cue to do the right things here. You'll know when. Okay, I'll share my screen and I'll start with, if I can find it. Okay, I just, you're looking at my Windows Explorer setup for the data that I get. Well, let me back up a minute. We were originally going to work on the Tarantula Nebula and just kind of go through it step by step. And I really thought it might be easier to do one that is much simpler, because the Tarantula has 8 filters, and integrating the narrow band of hydrogen alpha, oxygen, sulfur, and nitrogen was challenging. And I said, well, I'll just take one of the ones that I did 4 or 5 weeks ago. It ran out of time because the weather's been so crappy this year. that I have only about 8 hours of data, but it's enough to get us started and understand the process flow and the kind of the analysis as we go along. So anyway, I set up my, just to show you, I set up my files this way. It just not the answer, it is an answer, and you do whatever works for you. But I have all the filters, these 4 right here, red, green, blue, and loom, for the individual data. And there's the raw data here. Then when I process it through the PixInsight, it goes into the process folder, which we'll do here shortly. And then when I get a final product, whether it's an intermediate red image or the intermediate RGB, I'll put it in Pix. So then I can come back and do it again. I mean, frequently I work on it for some amount of time, take a break, even days break, come back to it. Because it gives you kind of get down a path and say, boy, this is not coming out like I wanted to, so I have to go back. So I save intermediate steps to make sure I can do so. And then on the directory here, I have my master calibration files, just for convenience, because I'll use those as they go through the process. So I have my bias and my flats for each one, the filters I have, and the 2 darks that I use, 5 minutes and 15 minutes. Okay, just wanted to show you that. A new share. Okay, we're going to start off with the desktop of PixInsight. And I got to move this out of the way. Okay. People ask, well, what's the right workflow? All I can tell you is how I do it. I'm not an expert. I just have some amount of experience. I've used the words before. Experiment, try things, read tutorials. There's lots and lots of excellent work on the PixInsight resources. There's millions of YouTube videos. Some are good and some are not so good. And then finally, after you do that, do some more experimenting. That way you just see how you learn from those operations. So I think what I'll do is to start off with asking Ann and Alan, what you have a set of your red data. What do you do? What's the first thing you do?
So the image calibration, or yeah, I guess blinked to make sure you. Yeah.
I gave you a clue there, didn't I?
Yeah.
We're doing.
I like to look at each image and find out which one has satellites so that I don't include those in my process.
Funny. Yeah. Oh, dang it. Something I learned from Alan. I think I should be able. Yeah. Yep. See, look at this. Alan taught me to just double click on the desktop and it takes you to the folder you were just at. So here's the red data. So I'm in Blink, and all these are on the process. Maybe come back. Let me back up just 1 second. See this. There it is out of the way. All the processes are here. And I don't use all of them by any chance. Some of them are scientific, and some of them I just have no idea what they're for. But anyway, what I did, I took the what I used and then created process icons and put them in that order. So okay, so that's the general workflow, top to bottom, not necessarily specific order, it's general order. And
hey Merrell,
sure.
Can I ask, are all of those actions native to PixInsight, coming from a Photoshop world, and how you add the plugins? I'm curious, is that native or things you add in?
I think, yeah, the answer to the question is yes. Some of these are scripts, because we're going to do that script next one. That people, this is an open source program that they let all the geniuses that are out there, they can write their own stuff there's some really fabulous shortcuts and scripts that just work. And but so the answer is yes, it's all native. It's all on. They make it available to you. It's all comes once you buy the program once. All these updates that people do and get approved, they're available to you. That answer your question?
It does. Awesome. Thank you.
Merrell, can you explain what the yellow line is? The vertical line on the right side of the screen. You have all your processes on the right side of the yellow line. Is there a reason?
I had no part of this.
Okay.
That just came. I mean, that's just kind of separates. You know, I guess I don't know. It's just always been there. So that's all. That's something that Pix did. And so okay. So what Ann says, we want to see any satellites went through your images you took, and these are 5-minute images. And I don't know how many I have there, but 23 of them, 24 of them. So we're loading them up. And what Blink does is that you can go through them. My process, once I take them, I run it through a program called CCD Inspector. It tells me what the FM full width Hz maximum to give me some of their gross discards. Then I transfer them to this program, so we just look at them. So we're gonna go down them and just take a look at them. And so you see I'm going down the list, and oh, there you are, Ann. So let's not do that one. In fact, the way I do it, you can get rid of this one. I just remove it to my reject folder, and then I'll get rid of that, and then just keep on going. Oh, there it is again. I guess those 2 satellites. And so we got 2 that I really don't want. It probably would go away by the rejection methodology, but why? So what we have now is you're just seeing, and you see the difference of the contrast of it. Because as you know, the last several months were really crappy. Sometimes real high thin clouds, they do that kind of stuff. I wasn't willing to throw the data away. So anyway, so we discarded the ones we don't want. So then we can go ahead and close Blink down. Okay. So now what's next, Alan?
And this is the image integration.
Okay, the first thing we want to do is calibrate. And so what we'll do is we'll add the red files, all the raw data. And this is the image calibration.
Image calibration, excuse me.
And then what you do, you choose the folder that you output directory. You want to put it in. I put it in my process. And okay, I got the bias. The one neat thing about it, once you create these icons, you save them, load them up. When you load up PixInsight, they're all there with your settings, the ones you're familiar with. So my bias is here. My dark is already put in place. Now, the only reason I ever change that if I go to hydrogen alpha, which I normally do at 15 minutes. And then I got to go find my master flats. So I've got to go back here. I'm a master flat for the red. So I can look for the red master flat. Keep it in a library. I have a rotator that I have to keep. What angle is it from north? That doesn't have to be 0 degrees. Okay, so we're going to execute it. This is execute globally, and it won't take too long to do so. And what it's doing is applying the flats, the darks, and the biases to each one of these frames.
I think
And
we could do a whole nother session on how to create your master flats, master bias, master dark.
That was going to be my comment.
Next question. Okay. Well, yes, and I think it's different. It's different. Depends what kind of camera set you have. The one-shot camera, one-shot color cameras, I'm certain are different than the different filters. Okay, so we've calibrated them, and now what's next? We want to align them because we got to make sure all the stars and all the images are lined up. So we got to choose a reference. Well, the way I do,
I guess I did the cosmetic correction next, but I guess
I told it the other night, I've never had to use, other than that, the image data that we got from offline at M33.
yeah. Okay.
If you need it, use it.
Yeah, I guess when you're looking at them, for the first time, you can zoom in and see if you see any dead or hot pixels there, or hot pixels anyway.
I don't have, I mean, the hot pixels go away, I mean, for the most part with the calibration.
Yeah, that's true.
If you have a bad column or a bad line or a bad row, that you might need to. I just have never had to use it other than that one time.
Okay.
So what we're going to do next is it's asking me to pick an alignment reference image. So every image is aligned to a specific one. Well, the convention I use, I look at my luminance, it's the first 7. It's just what I do. So I always remember which one it is that I use forevermore. Okay, so what we're going to do now is to add the files. So we were on the reds. And if I'm doing it just too fast, don't hesitate to ask.
Did you say you used the first luminance image for your reference?
The first one has got the ending in 7.
7. Okay.
Yes. Just something that I
Just so you can always use
the same one. And so
so you always use the same one.
What's important, they all get aligned to the same image. Now you can do them independently. Then you have to do it. Then you have to register them later on. But I can save steps this way. Okay, so what we did in the first one, we processed them. Now you can see the C here. That means they've been calibrated. Now we need to register. So okay, the output directory is going to be the process folder again. We'll come back to those. And away we go. Now, crap. I'm generating drizzle data, which it does add some additional aspects to your images, but this new script that I learned about just a few days ago, the NSG, normalize signal something, I'll show you in just a minute, doesn't require it. And so what it needs is the, and this script right here is included in all the processors. You can find them, everything that's there. Okay, so what this is normalized scale gradient. You saw how the varying backgrounds of the images we went through, how they changed from, I mean, those are several different nights, but this will do a fabulous job of normalizing them. And so what I look for now is the ones that are the C and R. They're calibrated and now registered. Okay. So I'll just select these. And what this does is asking for a reference as well. And this is the altitude. So the highest altitude is what they recommend as the reference. Okay. I think.
But do you store that altitude information in your file name?
It's in the FITS header.
Oh.
Yeah,
Okay.
I mean, this is the default information that's in the image when I take it.
Okay, so this process pulls the altitude from the FITS header and then you can see it in this window.
Yes,
Oh, that's nice.
yes. Well, I mean, there's lots and lots of information. If you're looking at FITS header, there's a lot of information. It
But
just,
but this process, normalized scale gradient, pulls that out for you.
yes.
Okay.
Okay, so we're ready to run, I think. Here we go. Oh, invalid output directory. Well, I guess it
Wait a
didn't,
minute.
did I?
Wait a minute. I want to back up just.
And this was added in the last version of PixInsight, this normalized gradient or normalized scale gradient.
Yes, it's literally days old.
Okay.
Guess I better update.
I have a question.
Sure.
How did it know the altitude?
Oh, every image has a header,
I know.
and in that header is a bunch of information, and that particular process pulls it out of the header for you when it loads the file.
Right, but how did the
And
header,
that-
how did
and I
that
think
information get into the header?
But
Oh, when your telescope takes a picture.
and the mount has information. I mean, I tell you what, when a little bit after I get past this, I'll load up a raw image, and we'll take a look at the header.
I'm just wondering if mine,
That's
if
a
it
good
comes
question.
out of my camera that way.
I think
Yeah,
so.
I don't know if like a portable mount would do that. It would depend how you're pointing your telescope with software, or I don't know.
I don't know. That's the reason I was asking. I'm going to have to figure that one out. All right, thank you.
I would bet you have the information stored in the FITS header. I would just bet. Okay, we're still trying to get the
Hey, we got one other question, Merrill.
Sure. Yes.
Go ahead. You had your hand raised?
Oh
Yeah, I was trying to find my mute button here. So let's see if I can make my question. So what you're saying is a lot of the information where your data source is coming from is actually from the mount, and so that's how you're basing a lot of this information.
Well, yeah. Let me finish this process here, then we'll take the version, take a look at a FITS header. It's embedded in the image, and I'll just bet you money it's in most cameras and mounts feeding the data to your whatever program.
Well, I don't have a mount as such, so I'm only looking at the data that I can get from maybe a software application. So I'd have to figure out how we can convert that. But I didn't know if you'd ever. Are you familiar with that kind of?
I would think you'd have to go to something like the Telescopius, where it shows when the object is the highest in the sky. And
Well, if you're using APT, it's what I use, and it gives you directional information as far as when you're taking the picture and what you're taking the picture of. So would that be something? And I don't want to derail the conversation, but
That's good. Well, Alan said you can go to Telescopius, you can tell what's the highest point of the night. But I start off as soon as it gets dark and then go to 3 o'clock in the morning. So it has different altitudes throughout the whole night.
Yeah.
And so what it chose for the reference, theoretically, the one is pointing the highest altitude has the least amount of atmosphere you go through, and therefore theoretically should be the best image you have in this group. So it's trying to normalize this. And the thing that I found on this was so cool is that DBE, which we'll get to in a little while, is usually a tricky process. At least it has been for me. And this almost makes it go so easy. And I've had very limited experiences. It's literally days old. And so what we're doing now, what it did, it took the registered data, the calibrated data, and put it into the image integration. So all we have to do now is integrate it. And this is all via the script. All this huge amounts of mathematics is being
Looks
handled.
like it appended the file name with an NSG for neutrals. What was it called? Neutrals. Normalized scale gradient. Okay, and then you clicked on image integration and it already loaded them up for you?
Loaded everything up for me. Just had to execute. Now this is the linear rejection. There's probably not much there. You can see it rejected some minor stuff. So we throw that in away. The low, I don't think you're going to have anything. No, nothing. Okay. And what I'm doing up here, I should have talked about toolbars a little bit. These are the ones I found really useful over the years. I have the preview pane, which is pretty here, and then you got your mask pane, and then this is your linear stretch pane. All the rest of them, there's lots and lots to choose from, and I'll be glad to send a screenshot of this to anybody who wants it, just to have. Okay, so now what this button here is the program linear stretch. So that's what the red looks like from that image. But to me, it's so consistent. It's flat.
That's beautiful.
Yeah, for just something that never did before. I mean, it's just I never had this before. I had to do all this manually, and some people use the weighted program that utility that stacks them all and puts all the information in. I think you tried it in.
Yeah, it doesn't work very well.
It's so complex that it doesn't even recognize my master darks, which obviously is critical. So I always do it by hand up until I found this, and this is just pretty cool. Okay, Alan, you're up next here. What do you see wrong with this image?
You have to crop the edges.
There you go. So we'll have,
but you don't do that yet.
Yes, exactly right. You're coming along really fast. Okay, so we now have the red file. So, but I'm going to change the identifier.
And Merrell, maybe when you hit OK, can you show people how to see the FITS header? So maybe in the background, Rick, you could open up your PixInsight and one of your images and see what's in your FITS header.
Turn on the lights here. Yeah, that's good thought. Let me.
So it's under. Oh wait, just open up one of the images here.
View.
And then under View, FITS header, or was it Fit View?
Sorry.
No.
Didn't mean to close it down. I don't do this very often. It's
there it is under File, FITS header, and there's all that information we were saying is stored.
So you got exposure times, temperatures. I set it at -25. It's a 1-by-1 bend.
And you don't get this when you have a DSLR.
Oh, darn. So
Well, that's probably correct. But it's got your RA and DEC.
right.
Here's your altitude. It all comes from the mount. It tells you it's on the east side of the pier. Whatever.
I'm gonna grab the screen from you real quick.
Okay. Go right ahead.
So I know Merrell he uses Maxim DL to capture the images, which is integrated with his mount. So everything is connected. And so all this information can be stored when the camera takes a picture.
So I use an ASI camera. The ASI Air Pro is my camera controller, but it's also controlling what my mount is pointed to, right? So indeed, the information is all here. I've got
Excellent.
right ascension, declination, date, instrument. It tells me it's my ASI camera, telescope control mode.
Just a huge amount of information.
Wow, there is, isn't there?
But I didn't see altitude. I saw,
didn't-
R,
Well,
I
they'll
saw
get it.
RA and deck, but I didn't see altitude.
You can get it from RA and deck, I would assume, and the time.
No, RA and deck don't change.
But if you know the time, it'll tell you the altitude.
But I'm just wondering if that process,
Well, yeah. So
that
does
he
it
used-
calculate that, or
or does it need to pull it from the FITS header? You'll just have to try it. Normalized scale gradient may need a FITS header value for altitude.
I'm sorry. Generally, you can modify your FITS header, what information it requires or requests.
All right, you got it back.
And I guess it would allow you to manually pick one if you don't have the altitude, I would think.
I would guess. You just don't know which one is the
Right.
highest in the sky.
Yeah.
Okay, so that's okay. So what we have here, I have the M100 red, and I'm going to save it. I'm going to save it to my Pix file subfolder. That's where I store my intermediate stuff. Okay, so now we do know that we have to crop this because you don't want these black bands because you don't. It actually interferes later on. And if you look at the image, you've got noise. So we're going to have to get rid of the noise sometime in the process. Okay, so you want to tackle the luminous first, or you want to tackle the RGB? Anybody?
RGB.
Okay, well, the next thing is the channel combination. And so what this is looking for is it looks for R and G and B. So we'll pick the red, and we'll get the green, and we'll get the blue, and then we execute it. And it's still a linear image, so it has to be stretched or screen stretched. Oh my gosh, what's this?
Well, that's a green.
Okay, so what's next, Ann?
Background neutralization.
Outstanding. What this attempts to do is get you a gray background. And I just use the default settings. And see, I close that down, but it goes right back to where it's always there. That's one of the neat things. You just mess up, you close it, and as long as you've had it in your group of ones you use, it's always there. Okay, so that's what the RGB looks like. And so what do we need to do next?
Hey, Merrill, Brent's got a question.
Sure, Brent.
Hey, I wanted to ask real quick, can you hear me okay?
Yes.
Okay, sorry, I had to switch over to my phone real quick. When you did the combination here, your RGB were aligned because you did that alignment on the luminance. Ultimately, how did you make sure that your RGB was aligned when you were merging them together?
Well, the way in the star alignment here, it asks for what the reference image is. And for all the data that I have in my data set, it's all gets aligned to that as long as I use that image. I chose which one, and the one I always choose is the luminance, the first 7 in luminance, just because I remember it that way. And so every one of the files that I have is aligned to that image. So when you stack them, they're by definition aligned.
So all the R's were aligned to the same luminance image, all the B's were aligned to the same luminance, all the G's. So everything is then aligned to that one luminance. And
Yes.
then I guess when you align the luminance, you're going to align to that same luminance image.
Well, to save time, I already did those. We don't need
Right. So you've done it all, and you've got the aligned filter images there. The master's already done.
Yeah, I did blue and green and luminous actually yesterday. So we didn't need to see the same thing over and over and over again because it's the same process.
Right.
And so now they're stacked and they're aligned. They still got the issue with the
edge.
edge here. So, and what we say is next?
See the dynamic crop now, or the NCNR. Let's see.
We could do the crop, but why don't we do the crop? But the reason you can't get, you got to be cognizant of, you got to do it to the luminance as well. Well, tell you what, let's wait a little later on the process, just for fun. Because it doesn't matter when. Okay, so what you really want to do is see the gradients across the image.
Okay.
You want to get rid of the gradients, so that's the dynamic background extraction.
Ah,
So the gradient you're saying it's kind of reddish in the upper left, but darker in the bottom right.
That's correct. And what you want is the flat image in the background. Now, Alan, does this look familiar to you? The pattern?
It does. Visible dark video.
Sean something or other, and I mean Adam Block, he has his own method of doing it, and I'd say this is better and easier and works virtually every time. And the NSG made it even easier. So, okay, so what this does, it takes samples of the background, and then through its algorithm, it does its magic and levels things out. Now you have two different corrections. One's division and one's subtraction. I believe division is for vignetting, and the subtraction is for light pollution. I usually do both. So we're going to.
are these the default settings?
No.
Okay.
No.
How big are your samples?
150 pixels.
You can play with that too.
Yeah, you can make it big.
Yeah.
Well,
What I'm wondering about is if you don't crop it first, if you have to move some of these squares out of the area that has the black border on the right hand side.
yeah, the thing that's troubling me is that my luminance here. Okay, it won't matter, but
Yeah, okay.
it's. Okay, well, I'm not trying to, let's just finish this. So we execute this, and we create the image 206 DVE. See, it's a lot more flat, all the same stuff. I'll do it again on the subtraction. And I really didn't mean to do that.
This is a good chance to show us how to undo.
What it did, it created this one right here. This is the one we created, 206 dB. So it labels what the action has happened. So what I go back here, what I should have done is, see this right here, you can make an instance, and so if you do a process that you really like the settings, you create an icon. And so if I want to now have exactly the same settings that I change around, just double click it, it loads them up, and then you just execute that, and away you go. So this has been DBE twice.
Oh, okay.
Okay.
Yeah.
Both subtraction and division. So
Hey, Merrell, can I ask, so the boxes that were around the outside, does that imply that the corrections are kind of not touching what was in the middle of it, or that your target has to be truly centered?
no, those are just samples, and they take whatever data is in those boxes, and then the algorithm is based on that. If you take a look at, we'll just mess around for a second.
Yeah, you can have a whole lot more boxes than
Yeah,
doing.
We'll just generate samples per row. If I can do this.
And you can move the sample boxes however you want.
Just wherever you want to put them.
There's so many videos that show you different methods.
Okay.
But this is the one I have found works so well. And I don't know it's because of tolerance. It's probably so low. So you see the Lexus. Now it's taking samples at 5 pixels radius all across the board. And I have personally found that this doesn't work as well as this one that Sean, whatever his name is, developed.
Yeah, I know. I'm trying to put this in terms of what I do for Photoshop, and like I physically outline the area that I want to make sure that I leave untouched, and I don't know if the X's in that on your actual galaxy there would be negatively impacting the data in this particular example, but
Exactly right. That's exactly right.
got
And
it.
you can delete those X's that are actually on the galaxy.
Okay.
And some of the times, like if you had a large object, PixInsight will not put samples on your object. It will try to figure out what your object is and only put samples around. But then you're free to adjust it as you see fit.
Okay.
So
and here with all these X's, it's actually little bitty squares, and then you can, like Merrell did in the previous example, he made them a lot bigger so you can actually see them.
But it sounds like you found the big squares, 150 pixels, work better and they're easier to see and move around. So I'm going to do that now.
Visible Dark is the guy's website, YouTube channel.
I think I watched that one.
I learned that a year ago, whatever, and it's my go-to DBE methodology. Okay, so what are we looking at? What do we need to do next, and what are we looking at?
Okay, so you do the same thing to the luminance channel.
So are we done with the RGB?
Well, we'd have to crop it eventually.
Okay, we'll crop it. What else?
Okay, let's see.
We have to stretch, histogram stretch eventually.
You're farther downstream than you should be. What we need to do now is calibrate the color.
Oh, yes, yes.
You got what it has this photometric color calibration.
Oh, yeah.
What this does, it compares the color of the galaxies that are here, that are in your image and stars, to a standard white background. So the way I read it, it's based on light from the sun. So it's always the same consistency of color. Some people don't like that, but I think there's a nice standard way of doing it. So what you do, you use this program here, and what it needs to know where they pointing. So you just take one of those images again, and it says acquire image. See, I loaded up a blue raw image, and since the PITS data has the information in it, it says acquire image, acquire from image. So it fill it in.
You know, the last time you did that, it didn't make any sense. And now that I know what's in the fifth header, I get it now.
Okay, well, what I've tried is to search coordinates. You can actually plug in M100. It doesn't work nearly precisely as if you just use one of your images. So we're going to execute it. Go ahead.
So with the DSLR, I've used the search coordinates, or I guess I use, search coordinates. And I've gotten, let's see, what is it? Astrometry, something that will give you the exact.
Astrometry, right?
Astrometry, thank you.
Whatever.
Yeah.
ASTRO, whatever. But it's online plate solve, basically.
Yeah. If you don't have the fits.
Yes, but the fits header. But I think it even. Let's just look. I think if you put M100 in here and does a search, it would give you the data, the area depth of what it thinks is there. So, all right, so we're going to execute. It's going to compare the colors that are in these stars and galaxy and everything to the standard white. And it's going to try to match them up to some curves. And theoretically, when it gets all done,
Merrell, when this is done, can you show us how to use the history box to go back? Like say we don't like the results of this or something.
Good question. That was it. Okay. So what it looks for is the white balance, and apparently it's trying to get a curve fit to these lines. And I guess if they were, I've always seen them aligned close enough that it always did that. So you just close it down, and close it down, stretch it again, and there's the color, albeit not saturated real well, but that's okay. All right.
Bye, Cameron.
He had to go.
Good night, Cameron. Yeah, he's got to work tomorrow.
Oh, okay. Well, okay. So what we're going to do here, we starting to see the color. It's got some blues in it, and you got a little yellow here on this star, and you got some blue on these stars. I don't know whether you can see it on Zoom, but we do want to, before we leave here, we want to saturate it, but we may want to go ahead and get rid of the noise. And one of the other things I got from Sean, which he got from somebody else, the multi-scale linear transform is one of the tools with the noise reduction settings here. And they're almost universal. And I sent this in the email. I sent you my project, my template. Those settings are in that template for Alan and me, excuse me, and Ann. So you just drag it over to it. And it's going to attempt to remove the noise. See, it got a lot smoother. I don't know if you saw that. There's what it was afterwards. Here's what it was before. Can you tell the difference? I don't know whether the resolution is good enough.
It looks less grainy, definitely.
Well, okay, so you want to do that. Now, the one thing that, if in fact later on you don't want to put your noise algorithm over the signal, so how do you create a mask? The masks are powerful things that you use to protect your data. You know how to do that?
Well, that started it. Let's see.
The easiest one for me is the range selection.
Range selection.
If you want to get the whole thing, now you get, if it's just the stars, you can go to the star mask. But so when you do the noise reduction and you want to protect your signal, this is really touchy here.
Yeah, that's one I haven't used.
It creates a mask that is flexible and usable. I'm changing the settings really, really low here. You see it's starting to show up the mask. That's too much.
And you would use this before the multi-scale linear transform?
It depends. It's if you want to do it, if you want to protect your data, yes. Wrong direction. Well, it is really sensitive. Okay, we're starting to get the mask, and let's increase the fuzziness a little bit here. Okay, so we'll call that the mask, and close the real-time preview. I'm moving very fast. I shouldn't be doing this, but that's the real-time preview. Remember, so you can see what was going on with those settings. So now I have a mask that I can drag over. And the red conceals the signal. So if you wanted to do a noise reduction, protect your data, your signal, you do that.
Oh, so that's what a mask does. It puts basically, like, I get it, a mask over things you want to save, and then you can process other parts of the image without touching the masked area.
Okay, and you got this is your mask toolbar up here. What I did, I just turned it off. It's still there, you just can't see it. When you see the brown here on the edge, that means there's a mask on. And see the green check mark here? That turns it on and off. You see how the brown goes on and off? Okay, let's assume that I want to do something to the signal and not the background, so I invert it. What do you want? You need to look at each image and say, okay, what is it I want to accomplish? And each step of the way, what is it? What's next? What do I want to accomplish? And masks are a great tool to use.
So if I wanted blue galaxies, this is how you do it.
Well, probably. This has got some blue in it, so and then I just get rid of the mask to turn it off. Okay, so we now have one last thing before we stretch it, and I think then before we stretch, we're going to crop. Is let's get a little color saturation. Rick, you played around with this last time. And just bring it up. I'm gonna go across. You know what I'm gonna do? I'm gonna put that mask back on there. And I'll tell you why. I'm not anxious to add color to the background.
Ah, there you go.
So I'm just gonna add saturate because there's still noise in there. So right. I don't increase the noise saturation. Okay, you start to see a little bit more color coming in the galaxy, and a little bit more. On my end, anyway, I can see these stars are starting to turn bluer. This one here is starting to turn a little more yellow. I've got a little red star here, but I'm starting to see blue in here. I think that's all I want to do right now. And we'll come back to it because we can do it. Alan, you said you do this at the very end.
Right.
So I think we do it. I do it throughout. I'll put it that way. Okay, so this is our RGB. Okay, and the thing that's troubling to me, I don't know why my luminance is so big. It should be all the same. We'll find out whether or not. Okay, the way you do the dynamic crop. Hold on a second. Is to outline it in the image you want to do that has the problem. So you just draw a box. And then since the information is in the dynamic crop, you just bring it over to the luminance and it's exactly the same image.
Oh, okay.
So the check mark applied it to the RGB image you had selected, and then the little triangle you dragged over to the luminance, it applies the same process, same settings to the luminance.
Yeah,
or to whatever you drag it to.
When you try the tarantula, you have 8 filters, and you're going to have 8 different sets of data, and you want all those crop, because once you change the geometry, I mean, you've got to go all the way back. And speaking going back, I'll go to your question. This thing has the ability to do a number of things. You get your Process Explorer. You can put these in where you want to. These are all the processes, same as what's up here. There's many ways to skin the cat here. This is the process console. What this does, it tells you the steps as you're going through it. And if there's errors, this is where it shows up, and you can go back and find out what happened, why it didn't work. But a real powerful one is the History Explorer, lower left-hand corner. And what we have is our M100. I'm selecting it. I can find it as RGB right here. And what that did, it steps you through what you did to the image. You can go back if you want to do it back to before it got calibrated. I just double click on it. It changed. This became an image when I ran it through DVE in initial state. Then I can go to the different parts of the color calibration before the dynamic crop, and so you can go back in time and saves you a lot of grief from time to time.
So after the oops, you can go to the history panel and go back.
Yes. Okay. Do we want to take a break and ask other questions, or I mean, I'm just been zipping through here. Everybody okay?
So we've done RGB, we've done image cropping, and just kind of reiterate the 4 or 5 steps here.
Well, okay, you calibrate them, you align them, stack them, then you start processing the color of it, the background, make sure it's flat, and getting to a place where now it's ready to be stretched.
Okay, so that's where we are right now, ready to stretch it.
This one here, yes. Now we haven't done anything to the luminance, and I'm puzzled why the luminance seems to be a different size, but
yeah, when you look at the star at the edge, it is a different size for some reason.
It's I just don't know how it maybe I used a different one. Let me see here. That's where you got different workspaces you can go on. That will come back later. Because one of the neat things about this, this thing should line up exactly.
Yeah.
Get it to the right size, that is. I may have to do the luminance, so I really didn't want to do that.
Well, that might be something we can talk about next time. I mean, we're getting here about an hour and we've learned a lot. And I can't wait to try all this on the data sets that I have.
Okay, well, let me this. Do we want to go ahead and do the luminance to the place where it's being stretched, or you want to just mess with the color and stretch it and then kind of see what that looks like and then call it a night? Because we can pick this up right where we left off.
How long will it take to do the luminance?
Well, same amount of time, about the same amount of time as we took here. Except you don't do color calibration, but it has different steps in it. Because one of the things that you do with luminance, that's where most of your data is. Because that's, if you think about what a luminance, a clear lens basically with maybe a IR filter.
Why don't you do the luminance? Let's go through that.
Okay. Well, then I'm going to ask the same questions of this mask is no longer good. You know why? Yes. You got a question?
Crop.
Because you cropped it.
Yes. Thank you. Good job. Okay, so the dimensions are gone, so it doesn't count. And I think Richard had to go. Okay, so what we have the same issue with the noise. One thing that you always want to do if you can, and the background, see it's got some amount of gradients. But on a luminance is where most of the data is. You want to do deconvolution. You remember what deconvolution does?
Makes the stars smaller. Gets rid of the atmospheric turbulence.
Yes, exactly right. And a way of doing it, I mean, there's several ways of doing it. They have some built-in settings here on the parametric, which kind of approximates it. The ideal way is to create the PSF, point spread function, based on these stars, which takes some time. Now, I do have a cheat here. Somebody wrote a nice little script, and I can create one and then use it. But so this is what the average of all the stars look like. It looks like they're tilted a little bit on the axis. And we would use that in this right here, the identifier, PSF. And then you start doing iterations here. I found that you want to get a close approximation, just use the parametric standard settings. Now, the one thing you got to do again is create a mask because you want to protect. I tell you what, this is going to be just rough. Let's just, we'll take the risk of doing. When you do the editing of this one here, Jamie, cut this out. So if we're getting close to people needing to leave, I'm just putting this on here. You'll see the stars change ever so slightly. They all got smaller. I don't know if you can see it. You got a little bit of halo here. See how the stars change? Mm-hmm. Now you can, there's a de-ringing here that you do it via a preview. Remember how to do a preview? You cut one here, do a preview. Because it's so math intensive. You want to do it on a small section. So you've got, when you did this, you got a little, hello.
Mine looked like that once. Yeah.
Yeah. Well, okay. Let's go back. So you got your go back on your preview without the de-ringing. See that the star got smaller, but it's got a little bit of halo, and the way you manage that is de-ringing. So this could take a lot of time. It's totally image dependent. So it's just the experiment. What works.
Mhm.
That looks better.
Well, that's,
Or that did.
oh, obviously that doesn't, that has to be near zero. Okay, that shrunk it a little bit. So we're going to use this for the entire image. So okay, so we've shrunk the stars a little bit, made an improvement on them. Delete the mask. Okay, so we're going to do the DBE on this one. Don't need to do any background neutralization or color because there isn't any. So we're going to execute here and stretch it. See, it got very flat.
Yeah.
And then I'm going to hit it one more time with subtraction. I'm supposed to close the image down, sorry. I want to execute it on that DB first go of it. Okay, now we're going to subtract it this time. Okay, there's our luminance dynamic background twice. Starting to look pretty good there.
Mhm. Yeah.
Yes.
And I want to run the noise reduction. Okay, it kind of got rid of some of the noise in the background. So now we have both the RGB and the luminance ready to stretch. Do we want to stop here? Or do we want to keep on? I mean, I can go all night.
This is probably a good place to stop.
And I guess like Merrell, if it is actually a different size
Shouldn't be.
image, then I guess you would go back to the image alignment process again and make sure they're aligned, crop them again.
Well, yeah, I mean, I did a dry run of this, and I don't know why.
Yeah, I know.
So it's a matter of doing exactly what we did with the red. Well, I'll tell you what. Well, I'm puzzled why it's different size.
Yeah, but anyway, that was just a comment is what you would do. But yeah, normally it doesn't do this where it's different sizes.
Well, there's something that's not meeting the eye because I use the same process in all of them. But having said that, this is a good stopping point because we'll.
So just to kind of summarize where we're going to pick up at the next meeting, we'll be going through image stretching, histogram. What are some of the other steps?
Well, you got all your post-processing of contrast improvements, sharpening, getting the color stretch right. What I'm doing, I'm just playing here right now to see.
Yeah, curves, transformation, color.
This histogram transformation, but you can do curves, which it's a different attack on the same thing. But you start to see the image come to life.
Yeah, you can start seeing some of the color come out in the disc.
Yep. And then we still got saturation to do. That's a little bit too much there. Go back. So anyway, I think it's a good place to pick it up.
Well,
Yeah, I found this really useful. The masking thing I had not learned about. That's going to be very handy.
Yeah,
you-
I hadn't used that either. That's a good
You
one.
can see a green cast to this. Can you do that? One thing, two of it.
very. It's hard to just. Yeah, I guess I do see a little bit
Yeah,
of green.
just green. I forget SCNRB stands for, but it took the green out because there's very little green in space, and so it took the green out. It shifted. If you look subtly, it shifted the
Uh-huh.
a little bit, and so I mean it's just starting to get depth. One of the things that this LHE, which we'll come back next time, it starts sharpening the actual galaxy.
All right. Well, Merrell, thank you very much. This has been incredibly helpful. And like I said, we've got some data sets. Merrill's working with M100 here, but we've got Omega Centauri. If you want to look at a seriously nice globular cluster, and we've got the Tarantula and Nebula. And what were the other two data sets we got?
Well, we got the galaxy now.
It's NGC 253, the Sculptor Galaxy. Is that?
Yeah, and NGC 6726.
While you're still on it, you may want to practice on just for fun with Martin's data. What he did. Can you still see my screen? Am I still sharing?
Yes, you are.
Well, the data he had was the left-hand panel, and because we were choosing this originally, I just said, well, I'll just crop that here, and this is the outcome. It's just
Wow.
best data I've ever dealt with before. And so,
And why did you do it again?
well, there's two reasons. One, Ann liked it close up.
Yeah.
But now I'm going to be able to do it on my own. I'm so excited.
But if you look at his hydrogen alpha, he took it over. I don't know, a bunch of different sections, but you'll see a distinct line when you stack them. And so I said, well, okay, I can probably get away with that, and do something around it. But I said, well, if I just crop it, here.
Yeah. That's the interesting bit anyway.
So, and then, but this is so, this is so much more complex than the M100. That's why I had second thoughts about doing.
Yeah.
And this is a couple. Well, this is the one I guess my final product and my driver.
Wow.
So I mean, even though it doesn't have a huge amount of data, it's okay.
Maybe we should have started with that. Started with that image. Show everybody what it was going to get to.
Well,
because I wouldn't have guessed.
The thing that I meant to say, and I didn't check my notes. I told Ann, I was talking to Ann a few days ago, that I try to find what some other people have done for the image I'm working on, and as the endpoint in mind.
Yeah.
So what you're working towards. Well, I could. The only thing was I could find on M100 was the Hubble and very close views of it, way more detail than this will ever be.
Right.
And, I kind of said, well, let me take this to the end, and there we are. Right.
Well, all right.
Okay, I felt like I went way too fast.
And that's the beauty of recording it on video. So
You can slow the talk.
go back and hit pause.
Okay, well, because there's so many things there's so many tools. If you want to compare the same exact, we're going to have the same. Let me go back here. Things like you zoom in on here you say want to know what that looks like on this one exactly. You put it right there. Did you know that? It's how you can do an analytical things, and you can create.
That makes them the same scale.
Do what?
How did you
makes
do
them
that
the same
again?
Scale, okay.
Okay. Well, say you're on this one here. You really want to zoom in here, and you're working on an experimental one on the left. So you just take this bar and just drag it right on top of this one. So it's exactly the same place.
Okay, that's cool.
Okay. Yeah, I had seen people doing it, but I never did figure out how they did it.
And you want to create just a quick and dirty mask. You make a clone. You drag it off in the desk space, and you put the mask there. And now you got a mask on this one. Generally, those are pretty weak masks, and so I don't use them much. But it depends what you want to do. Again, there's so many little tricks that we don't have that time to do that until later on, or somebody asks or somebody, because I use them so naturally, if you will.
Right.
That
Yeah, I have used that one before. I can't remember when.
And the different desks, the different workspaces, you can do at the same time on your workspaces. So anyway, there we have it.
So you can open up a project in each workspace.
Yeah, you need to have a lot of RAM, but yes.
I got you. Okay.
Anyway, so what we'll do next time, we'll finish stretching the RGB. We'll finish the loom, do the combination, and then do the post processing. But I would recommend that people just download your tarantula and just start, because
for the data we've purchased, there's no calibration necessary.
There's no calibration. They're not aligned. You have to read it.
Okay, so we start with the lab. Great.
And in fact, this NSG for his data is not even necessary. You don't even have to do DVE on his data. When the skies are so dark.
I was about to say, dark skies make up for a lot, don't it?
And outstanding equipment. And he does this for a living, so I guess it better be good.
So
okay.
What are you downloading?
I think he's downloading the data, the purchased data sets.
Oh, okay.
Yeah, I haven't had time over the past few weeks, so I'm finally grabbing the tarantula and the other stuff to start playing with.
All right.
It's a big download.
Yeah, they're all huge files, but you gotta expect it.
Just to be.
Ryan, you need to move closer to your microphone. We can't hear you.
Can you hear me now? A little better?
Yeah, there you go.
Okay. So how do I download this data?
So you'll have to have access to our cloud drive. And to do that, I will need to set you up and send you an invitation. So you need to send your email address to Rick, R-I-C, at memphisastro.org.
All right. Just writing this down. Thank you.
Absolutely.
I'm looking forward to processing it.
Yeah, you can download the PixInsight for a 30-day trial, and it takes like a day for them to approve your trial license, and then you'll be up and running.
I'm currently waiting on the application process right now. I've already sent them an email.
Yeah, it took like a day for me, and then I was able to download it. Have fun. I want you to be an expert in PixInsight before you show up at Rhodes. I'm just kidding.
It looks, it's a very great software package. I've never used anything like this. I've used Deep Sky Stacker and GIMP before. Both of those are free programs. So, I spent all my budget on hardware. So this is amazing.
Yeah,
definitely a step up.
We will have this installed at Rhodes, at least on an observatory computer, so that students can use this software.
Awesome. I'm really looking forward to it. Thank you so much.
I know it's in my future. I'm still a Photoshop user. So this is the first time I've really watched a real run through. So that's why I keep asking the questions. I'm putting it in the mindset of my processing before. So
Sure.
real excited to see what you did here, Merrell, and really, oh gosh, I'm going to have a lot of learning to do to figure out this new program when I get to it.
Well, I started out using Photoshop and then I transitioned to this, but I still use Photoshop. I mean, it's got some tools. If you want to do some individual arm of the galaxy, you want to sharpen it, it's easy to do in Photoshop. You can't do that in PixInsight. So there's tools that in both of them that you can use. If you just had one, knowing that I've used both, I'll take PixInsight if I didn't have the other. That makes sense. Because this is strictly for astronomical or astrophoto.
Right.
And it was designed by absolute geniuses. If you look at some of their tutorials, the mathematics behind this stuff is just spectacular.
I'm curious. So I'm still doing one-shot color. I'll be starting to get into mono probably next year. What I'm seeing here is it looks light and day, like PixInsight, no joke for mono processing. I think you can get away with a lot more on the one-shot color on Photoshop, so I haven't really had to think about it. But all these other things you're having to think about seem to be a lot easier to structure here than maybe they would be over in Photoshop.
Well, if you look at the screen, they do have the debater on it, and so what it does is it takes your one-shot color and then breaks it into the RGB.
Yeah.
So then you just it's like you have the individual red, green, and blue images that I have on the left side, and you work with them just the same. And I suspect when I don't know if you take 5-minute images or 10, I forget. I think you said 10. You just have to calibrate them, stack them, just like you would with these guys. But it breaks them up for you, which I think that you have to do that anyway for your Photoshop, right? Don't you have to debater them?
Well, Deep Sky can't talk now. Deep Sky Stacker does the debayering for me during the process, so it spits out the RGB image as a TIFF file, and then I just go from there.
Gotcha. Okay.
Well, Ryan, just so you know, to graduate from any astronomy program at Rhodes, you have to make a presentation to the Memphis Astronomical Society 1 month. So, and you'll bring him up to speed on that, I'm sure. And I'm just kidding. It's. But,
he's not kidding. He's absolutely serious.
Ryan, I want to see you do this here in about 2 weeks. Okay.
All right.
All right.
I think Ryan has a ton of data from his own setup he wants to process as well. So he's going to be busy.
One-shot color camera, so it's a lot. I've done. I pulled up just some raw photos on my other computer. I was noticing how bad the coma is on the edges. Oh gosh, it's so bad.
But now you have some tools, and you can
tools for cleaning it up. Right.
Right. So whenever I submit my email, Professor Viano, should I use my Rhodes email or my personal Gmail?
So Rick just has this iCloud device, and so it doesn't matter. It's either one.
It's
okay.
It's not a Rhodes device.
Yeah, it's not associated with Rhodes, and whatever you prefer.
That's good. I was just wondering. I still haven't figured out exactly the limits of the Rhodes email.
You can use it for as much as you want or as little as you want. I try to use it only for Rhodes related things, and then I have another email for personal stuff and shopping and all that stuff.
Sounds good. Thank you.
Well, and Merrell, thanks for the text. I would have missed all of this tonight. I'm glad I joined.
You added a lot by being able to me to ask the question, what's next? Because you've learned a tremendous amount, and it made it easy for me rather than me just talk. And I get excited about this stuff, and sometimes I talk too fast. And but yeah, you added a lot. I appreciate that, and you too, both of you.
Yes, and
Come a long ways.
yeah, I wouldn't have minded that this would have been 2 or 3 hours long. It's fine with me.
Well, but I first of all, I enjoy doing this. If you guys ever have a question, just call me, right, whatever.
Definitely.
And we can use, we can set up a Zoom meeting anytime between two of you or with a group or whatever you want. I mean, I have a Zoom account we can use for anytime. Well, all right.
So great.
Thank you very much, everybody. Merrell, thanks for all the work you put into preparing this. Ann and Alan, thank you for your help in doing it. And I'm going to stop. I'm going to hit the stop recording button here in just a second. That doesn't mean we have to hang up, but I think this will be the end of our formal part of our program for tonight. So thank you very much, and we'll see you next month.
Did this meet your needs, Jeremy?
Yeah, just a reminder that this group meets roughly the 4th Saturday of each month around the time of the full moon. So we'll send out an announcement for those of you who are on our subscriber list for the next meeting. And reminder also that our next meeting, our next general MAS meeting is July the 9th. So that'll be the second Friday in July because of the 4th of July holiday. We normally meet the first Friday, but because of the holiday, the July 4 holiday will actually meet July 9. So just those two announcements, but we meet once a month for the Astrophotography Focus Group around the time of the full moon. So our next meeting will be about the 4th Friday or 4th Saturday in July.
24th. 24th is what the calendar said. Do we want to start it? Do we want to start at 8?
It's a good question.